Let's explore the fascinating world of E, also known as Euler's number. Euler's number is approximately equal to 2.718 and so on. It is a fundamental constant that appears throughout mathematics and the sciences. It represents the natural growth constant, and it plays a vital role in various fields, including biology, finance, and physics. Now let us define Euler's number. Mathematically, it is defined as the limit of the expression 1 plus 1 over n raised to the power of n, as n approaches infinity. In simpler terms, as n becomes extremely large, the value of the expression gets closer and closer to. The value of Euler's number, E, is approximately 2.71828, and the decimal representation continues infinitely without repeating. This makes E an irrational number, which means it cannot be expressed as a simple fraction. Euler's number has a deep connection to the natural logarithm. The natural logarithm, denoted as ln, is the logarithm to the base e. In other words, e is the base of the natural logarithm. Therefore, the natural log of is equal to 1. In biology, Euler's number appears in the context of natural growth. For example, the population growth can be modeled using the formula P of t equals P subscript 0 times e raised to the power r times t, where P of t is the population at time t, P subscript 0 is the initial population, r is the growth rate, and is Euler's number. The other applications are like bacterial reproduction and cellular division. In finance, Euler's number is used to model continuous compounding. The formula for continuous compounding is given by A equals P times e raised to the power r times t, where A is the final amount, P is the principal amount, r is the interest rate, and t is the time period. E helps in understanding exponential financial growth. In physics, Euler's number finds applications in radioactive decay, damped oscillations, and wave functions. The number of atoms remaining n of t after time t is modeled by the equation n of t equals n subscript 0 times e raised to the power minus lambda times t, where n subscript 0 is the initial number of atoms, lambda is the decay constant. One of the most remarkable properties of Euler's number is that the derivative of the function e to the power of x with respect to x is equal to e to the power of x. In other words, e to the power of x is the only function that is its own derivative. This property makes e exceptionally important in calculus and differential equations. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.